In this video, I want to apply what we just learned about the equation of a circle, which we built from the Pythagorean theorem, applying the Pythagorean theorem in distance, and see what we can figure out. Find the center and radius of the circle x minus 1 squared plus y plus 3 squared equals to 37. All right, now recall that we developed this equation, x minus h squared plus y minus k squared equals 2 radius squared. And the value of this is that it's the equation of a circle written in a very convenient format. That here h is positive 1 because x minus 1 matches x minus 1. So h is 1. And over here, what's k? Well, y minus k, and this says y plus 3. Well, y plus 3, think of that as y minus negative 3. And so this is like saying y minus negative 3. K is negative 3. So we've identified h and k, and r squared is 37. So now we can write down the answer. And by the way, I expect a sentence on these. So, don't write a coordinate point and r equal a number. I want a sentence. The center, communicate. The center is 1, negative 3. And I'll use a semicolon. You don't have to do exactly like me, but I like a sentence of some sort. Semicolon, the radius is the square root of 37. So don't forget to take the square root of the number on the right side. Well, that's basically it. When the equation is written in the standard form, it's a very convenient form for finding information. It gives you all the information that's key to it. We can immediately write down the center. We can immediately write down the radius in this format. It's kind of like when you learn about the equation of a line in another algebra class. Y equals mx plus b is the most convenient format for a line because m is slope and b is y-intercept. You can just look at the equation and immediately recognize those key aspects of a line. Same here. We can look at it and immediately pick out center and radius. Let me do one more of these. The center and radius of the circle, x plus 4 quantity squared plus y minus 2 quantity squared equals 49. So the center is what? Well, after you do a few of these, you'll really start recognizing that, well, the center is the opposite number here. It's x minus negative 4. Negative 4 is the x coordinate. And y minus 2, positive 2, is the y coordinate. So it ends up being, in practice, the opposite numbers are where you get the center coordinates. Center is negative 4, positive 2, and the radius is, it's going to be the square root of 49, so which would be 7. So I didn't write r squared equals 49, but you would find it by taking the square root of 49. So there we go. Once you learn the pattern, this is very, very simple, very easy. And one observation I'd like for you to make is, if you had a circle of radius 7, now I'm changing the subject a little bit here, but suppose you had a circle of radius 7 that was centered at the origin. What's the equation of that circle? It would be x squared plus y squared equals to 49, 7 squared. So there's the equation of that circle. And now if I take this circle and shift it, if I go 4 units to the left and 2 units up, I move the circle up to here. So I move 4 units to the left. That replaces x with x plus 4. When I move up, I replace y with y minus 2. All right, so I just want to plant that seed in your head because later we have a chapter on functions, and we spent a lot of time studying function transformations. And so, in a sense, this is related to what you do with function transformations. Is we've taken the circle and we've shifted it horizontally and vertically. So you'll see that that issue again, and perhaps you can relate it to what you see here with circles.